G'day and welcome back to Mathematics, where today I'm going to take you through a quick little lesson on the cosine rule. So if you want to learn how to use the cosine rule in less than 20 minutes, I'd say you're in the right place. If you have no interest in learning the cosine rule, you're in the wrong place, and you should like and subscribe anyway, and then move on with your life. But thanks for stopping by. Let's go through the cosine rule. We're going to start with a triangle very similar to our sine rule video. We have three angles A, B, and C in capital letters. Across from these angles are lowercase a, lowercase b, and lowercase c for our side lengths. Now for today, we actually don't need capital A and capital B. We can get rid of these. All we need is an angle and the three sides, which gives us this relationship, an equation known as the cosine rule. Now, as you can see, it's a little bit of Pythagoras, c squared equals a squared plus b squared, with a little bit of spice on the end with the minus 2ab cos c. So the scenarios we can use this equation in are if we have all three sides of a triangle, any triangle, we can use the cosine rule to figure out any of the angles. So if you have three sides, we can use this formula to find an angle. Or if you have one angle and you have the two sides next to it, you can use this formula to find the side length, which is across from your angle, which is lowercase c. So I'll show you a variety of examples doing both of these, and then hopefully you can go in and try some yourself. Let's start off with our first one. We have, before we do that, if you don't believe me that this equation works, here is a quick little proof of the cosine rule. If you want to pause and ingest that, it's obviously very interesting. Or you can do what I do, which is to ignore the proof and just have faith that the equation works and use it anyway. So let's do that instead. Here's our first one. We are trying to find the value of A, which is this side length over here. So noting we have an angle and we have the two sides next to it, we can use the cosine rule. We have this angle. Here's our cosine rule from before. We're going to say 42 degrees is our capital C, which is across from what we're trying to find. I know it says A there, but for the purposes of this formula, we're actually going to pretend that this is a little lowercase c. So ignore the letters they give you and just use the letters that you need for the cosine rule. So capital C across from lowercase c. Your other two sides are A and B. You can put those either way. I'm going to go A down here and B up here. You can swap those and it's going to give you the exact same answer. Just trust me on that one. Okay, we have our formula. We have our sides and angles labeled. Let's chuck some stuff into the formula and do a bit of maths. So on the left-hand side, C is now becoming A, which is alphabetically very confusing. But our A and B are the 14 and 21, which are getting squared. Then we're doing take away 2 times A times B, and we're doing cos of the angle provided, which is 42 degrees. Now, this is our values substituted into our formula. Personally, this is not what I'm going to put into my calculator because I'm not trying to find the length of A squared. I'm trying to find the length of A. So if you want to do this in one convenient hit, we can just take the square root of this, and the square root of this expression is going to go from A squared to A and find us the side length. So this is what I recommend you feed into your calculator. Now's a good chance to grab your calculator and check that you can open a square root and type this value in and see if you get the same answer as me, which is equal to approximately 14.14 units. Okay, so recognize which formula you're using, substitute in your values, and for finding a side length with the cosine rule, don't forget to do a square root or your answer will be way too big. It'll be like 200, which is clearly wrong. So don't forget the square root. Okay, there's your first example. If that's making sense to you, here is one for you to try by yourself. So by all means, pause the video now, have a crack at using the cosine rule with this triangle to find the length of Q. Very similar to what we just did. Okay, there's your pause chance. 3, 2, 1. I'm not going to run through the entire solution, but if you had a crack at this and you got a value of, drum roll, Q is equal to approximately 19.23, then we probably both did it right. So congratulations on your correct answer. Okay, now we're going to take our cosine rule and I'm going to show you how to use it to find an unknown angle. So before we do that, we're going to have to rearrange our formula a bit. Here is our cosine rule from before. We are going to rearrange this equation to try and get the cos C by itself turned into a more usable form for finding unknown angles. So the best way to do that is we're going to take the minus 2ab cos C that's on the right hand side and we are going to plus it across to the left. So now it's positive and on the left hand side. We are going to get rid of the positive c squared on the left hand side by minusing it across to the right. So we have a squared plus b squared minus c squared over on the right. And now to get the cos c by itself, we're going to take the 2ab, which is multiplying on the left hand side, and we're going to divide it across to the right hand side. So we get cos C is equal to a squared plus b squared minus c squared, all divided by 2ab. This is the formula we're going to use to find unknown angles. So like I said, when you have all three sides of any triangle, this is the formula we can use to find an unknown angle C. Whereas the sine rule from the previous video, we needed to know one of the other two angles first to find the unknown angle. Whereas the cosine rule, we only need three side lengths. So it's different formulas for different scenarios. All right, let's have a go at using this formula for this example here. We have three side lengths of 25, 35, and 19. We are going to find the value of the angle W. So most importantly, the angle that we are trying to find, we are going to label this as capital C, which means across from this, which is the 19, is going to be lowercase c. A and B can be either of the other two sides. I'm going to once again put the A down here and the B up here, but you can swap those and trust me, you will get the exact same answer. We have our cosine rule to find angles. We are going to change capital C to be W, and then A and B are 35 and 25, and lowercase c is 19. So let's substitute the values from this triangle into our expression. So we have cos W is 35 squared plus 25 squared. Take away the 19 squared, and that's being divided by 2 times 35 times 25. Okay, now again, this is not what I am going to type into my calculator because this is not going to find me W. This fraction is going to find me cos W. So if we want to be as efficient as possible and only type one thing into the calculator, we can say, all right, so if this is cos W and I want to find W, to get rid of the cos, I'm going to have to do the opposite of cos, which is cos inverse, or inverse cos. So I'm going to type in shift cos into my Casio calculator. I'm going to type in the fraction and close the brackets. And now I can just type in one thing into my calculator without any rounding and get my answer nice and ready to go. So by all means, pause, have a crack at pressing shift cos, typing in this mess of a fraction and then closing the brackets. If your calculator is in the right mode and you've pressed the right buttons, you should get W being roughly equal to 31.7 degrees. So once again, when we have all three sides, we use our cosine rule, substitute in our values, make sure you pick C correctly, otherwise you're going to find the wrong angle. Type this in with a cos inverse and you get your answer straight away, nice and easy. If that made sense to you, this one is for you to try by yourself. Once again, pause the video and try and use the cosine rule to find the unknown angle B by setting 45 as little c, 56 and 40 are going to be A and B. Here's your chance to pause. 3, 2, 1. No solution once again, but here is the answer if you want to check that you did it correctly. The answer for B is approximately equal to 53 degrees. So if you got something different, let me know in the comments what you did wrong and I'll try and help you out if I can. Okay, that's how we use the cosine rule for sides and angles. Let's now have a crack at a few applications and then we're going to finish off with some HSC questions for both standard and advanced. So here is our application question. We have McGrath under surveillance by the government because of suspected tax fraud. This is fiction. All right, this is just purely fiction. This is not real, probably, hopefully. A surveillance drone is 4.6 meters from the suspect. That's this line over here. And then 1.3 seconds later, it flies over here, which is 2.8 meters away. Now, I somehow measured that these two lengths had an angle of 118 degrees between them. Maybe I had some sort of laser reader on my phone. I don't know. But we have this triangle here, and we're going to use it to find the airspeed of the drone in kilometers per hour, even though the measurements were given in meters and time given in seconds. So a few steps here. All right, let's get rid of all the faff and just leave the important part here. What is the airspeed of the drone in kilometers per hour? So to figure that out, I'm going to need to figure out how far the drone has traveled in 1.3 seconds. So to do that, I'm going to use an application of the cosine rule. I'm going to say this is going to be my angle C, which is across from what I'm trying to find, which is lowercase c. The other two sides can be A and B in any order. I'm going to put A on the left and B on the right, but you can swap them and I cannot stop you, but you will get the correct answer. Okay, because we are trying to find the distance that the drone has covered, we're trying to find a length of this triangle. So we're going to use our cosine rule for length formula. So C is what we are trying to find. A and B are 2.8 and 4.6, and the angle C that goes with the cos is the 118 degrees provided in the question. So substituting the information from the triangle into our equation, we get C squared is 2.8 squared plus 4.6 squared. Take away 2 times 2.8 times 4.6 times cos 118 degrees. Once again, before I type this into my calculator, I'm going to recognize that this is going to find me C squared and I want to find C. So to fix that, I'm just going to type it in with a square root. That's going to get rid of the squared for me. Now I can punch this into my calculator and get an approximate answer, a little bit of rounding here, but the length c, which is the distance that the drone has flown, is roughly 6.41 meters. Okay, now we have the distance and we have the time from before, which was 1.3 seconds. Let's figure out our speed. So to do that, we're going to use the good old-fashioned speed is equal to distance divided by time. This is average speed. We know what our distance is. We just figured it out. It's 6.41 meters. The question specified that the time that the drone was flying was 1.3 seconds. So here is our calculation to get our speed in meters per second. But we don't want our answer to be meters per second. We want the airspeed of the drone in kilometers per hour. So to convert this to kilometers per hour, a little bit of work to be done, but I'll show you a cool little shortcut. If you take your meters per second speed and you multiply this by 3.6, 3.6 is the magic number that turns meters per second into kilometers per hour. It does the whole conversion for you in one go. So that's what I'm going to do. So taking my 6.41 divided by 1.3, multiplying it by 3.6 to get it into kilometers per hour, gives us a final answer of this drone flying at roughly 17.75 kilometers per hour, which is not that fast. I could probably outrun it. Could I? Yeah, I could probably outrun it. I could definitely outdrive it. So good luck, government. You'll never catch me. On to a couple of HSC questions. This one is from a standard maths exam from a few years ago. It's pretty straightforward. It's just, here's a triangle, PRQ, and we want to find the size of the largest angle. So, which of the three angles is going to be the largest? Well, through the power of eyesight, I can see that Q definitely looks like it's larger than P and R. And that's actually true. A property of triangles is that the largest angle will be across from the largest side, which means that Q is the largest angle and R would be the smallest angle. So as soon as we figure out what angle we are trying to find, we now say, all right, I've got a triangle and I've got all three sides. If I have all three sides, I can use the cosine rule to figure out any angle. So I'm just going to call this angle here as my capital C, which means that across from this, the 98 is going to be my lowercase c. For the purposes of my formula, I need the A and the B, so I'm just going to say A is the 66, and I'm going to say B is the 53. Swap them if you want, I don't care, live your own life. Okay, here is our cosine rule that we use to find unknown angles. So we're just going to keep C as C because there's no other label here. We're going to be doing on the top 66 squared plus 53 squared, take away 98 squared, and then on the bottom we have 2 times A times B, so 2 times 66 times 53. Okay, once again, being as efficient as possible, I'm not going to type this into my calculator because I want to do it in one hit, and I don't want to find cos C, I just want to find the angle C. So to get rid of the cos, I do inverse cos or shift cos on the calculator. Okay, so inverse cos of the fraction from before. Don't forget to close your brackets and punch it into your calculator. If you press the right buttons and your calculator is in the right setting, you should get an answer for the largest angle in this triangle of roughly equal to 110 degrees and 24 minutes if you want to be precise. So there you go. Nice, easy, straightforward standard maths question. Let's finish off this little mini lesson with a question from an HSC exam from the advanced course. This again was from a fair few years ago, but still a good question. Here is a triangle and it says find the value of x in the triangle below. Okay, cool. So because we have an angle of 60 and we have the side length across from this, which is 13, this is going to be a good application of the cosine rule. If we had two angles that we were working with, we could use the sine rule, but we don't, so we're not gonna. Let's move this over here and let's say, all right, let's use our cosine rule. We're going to say 60 degrees is our angle C because there's no other angles to work with. That tells us that the 13 across here is going to be our lowercase c. A and B on the other two sides, I'm going to put A down here and B up here. Okay, let's dive into our cosine rule formula. This is the one that we use to find side lengths because we're trying to find x, which is the side length. That makes sense. Let's substitute our values from the triangle into the equation. So c squared is becoming 13 squared. Our A and B are x plus 4 and x minus 4 that are being squared. We're then doing take away 2 times A times B, which is the x plus 4, x minus 4. And on the end, we have the cos angle being cos 60. So now the goal is to simplify this equation as much as possible, do a bit of expanding, and then hopefully try and solve this quadratic equation to find the value of x. All right, so starting off with the easy part, 13 squared, 13 times 13 is 169. Now we've got to know how to expand some perfect squares here. So to expand x plus 4 squared, all you got to do is square the first term, square the last term to get the 16, and the bit in the middle is the x and the 4 multiplied together and then doubled. So 4 times x is 4x, double that and you get 8x. That's the shortest and easiest way of expanding x plus 4 squared. Similar idea for x minus 4 squared. We're going to square the first term, we're going to square the last term, and don't forget, negative 4 squared is positive 16. And then in the middle, we have x times negative 4, which is negative 4x. We're going to double it to get our middle term, which is negative 8x. Okay, on the end, we have 2 times, well, this right here is called a difference of 2 squares. We have x plus 4 and x minus 4. We can expand this by just doing x squared take away 4 squared, hence the name difference of 2 squares. So we still have the minus 2 at the front. Expanding these two brackets becomes x squared take away 4 squared. And then on the end, conveniently, the value of cos 60 is exactly equal to a half. So we have a times half on the end. This is great because we have a times 2 at the front of this bracket and we have a times a half at the end of the bracket. And so those two are just going to conveniently cancel each other out and leave you with a 1. Okay, so I'm simplifying now. We have the x squared plus the x squared becomes 2x squared. We have 16 plus 16 is 32. The 8x, take away the 8x is nothing, so the x terms are gone. The 2 and the half, like I said, are simplifying into a 1, but I'm still keeping the negative there just to remind myself that I've got to apply it to both terms inside the bracket, which is x squared minus 16. So when I expand that now, I get a negative x squared and I get a negative 16, which is positive 16. Okay, now simplifying even more, I've got 2x squared take away x squared, which is going to be 1x squared. I'm just going to put this on the left for now to make things a little bit easier. So 2x squared take away x squared is 1x squared. I've got 32 plus 16, which is equal to 48. And the other side of the equation, which I've now put on the right to make my life a little bit easier, is still 169. Okay, that is the hard part well and truly done and dusted. Finishing it off, making a little bit of room. Subtracting 48 from both sides, and the right-hand side becomes 121. And now to solve for x, we just need to take the square root of 121. Normally we would take a positive and a negative solution here, but because we're trying to find the side length in a triangle, a negative length doesn't really make any sense. So we're going to go with the positive answer, which is x equal to 11. And that is the value of x in the triangle. So this side length here is going to be x minus 4, which is it's going to be 7. And this one is 11 plus 4, which is 15. But the goal of the question was to find x, which is equal to 11. So done and dusted, advanced maths, piece of cake. Okay, that's all for the cosine rule. I hope that made sense for the most part, and I'll still be doing a few more trigonometry lessons for advanced and standard in the next few weeks. I think next on the menu is probably doing a bit of bearings. So if you struggle with bearings and you can use some help, by all means subscribe and come back in a few weeks and hopefully I can help you out. That's all for today. Thanks so much for watching. Hope you're learning, and I'll see you in a new video very soon. Bye for now, not forever.